Hello ladies and gentlemen, welcome back to another video. Today we're going to be talking about the quadratic equation. So far we've been talking about finding roots of quadratic functions, and we've kind of had two main ways we've discussed so far. We've talked about factoring, so we can factor the quadratic, get our two factors and solve for the roots that way. We can do completing the square, which is kind of a big longer process to set it up and solve and figure out what the roots are. The last way we're going to talk about today is called the quadratic formula. And what's really nice about the quadratic formula is that it's going to work for any quadratic out there. You can use it to find your roots, all right? And basically, it's just a formula that we plug in the values of A, B, and C of our quadratic into. Now, a quadratic is in the form y, let me get the drawing thing on here, y equals ax squared plus bx plus c. So we're going to be taking those three parts, the a, the b, and the c, and we're going to be plugging those into our quadratic formula in order to find what the roots are, okay? And this is the formula right here. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This is a formula that you need to know. In fact, it's one that is probably expected to be memorized because it's something you need to just be able to pull out and use. Sort of like last year or whenever you learned about the Pythagorean theorem, you were told, hey, you probably should remember this one. This is one you're going to need. Same thing with the quadratic formula. You should know what the quadratic formula is. And it's going to be very helpful for these equations because we can pretty easily find the roots by going ahead and doing the quadratic formula. So the first thing you want to check is make sure that your equation actually equals 0. For the first two, we see that. For the last one, we're going to have to do something to make that happen. But then you just take those values of A, B, and C, and you plug them into the formula up there. So for this one, my A value would be 1, my B value would be 6, and my C value would be 8. So my formula would be that X values are going to equal negative 6 plus or minus the square root of 6 squared minus 4 times 1 times 8 all divided by 2 times 1. And then what you're going to do is basically you're going to simplify what's inside the square root, okay? You can do that in two steps if you want to square this and multiply this and then combine those together. You can just kind of do it on your calculator. However you want to do that, you want to simplify what's underneath the square root. So in this instance, I'm going to end up with 6 squared is 36. 8 times 4 is 8, 16, 32. So I'm going to have x is going to equal negative 6 plus or minus, and then again 36 minus 32 is going to be 4, and that's all going to be over 2. After you simplify whatever's underneath that square root, you're then going to simplify this square root here fully as much as you can. Now in this instance, I have a perfect square, which is nice, so it's going to become just the value of 2. So x is going to equal negative 6 plus or minus 2 over 2. Once you end up here, this is where you're going to kind of split it into two different equations. Okay, the plus or minus, we want to basically look at what each of those is going to give us. So we're going to have the opposite of 6 plus 2 divided by 2. And then we're also going to have the opposite of 6 minus 2 divided by 2. And those are going to equal two different things. The top one, negative 6 plus 2 is negative 4 divided by 2 is going to be negative 2. So x will equal negative 2. That's going to be one of my roots. And this one down here, I'm going to get negative 8 divided by 2, which means that x is going to equal negative 4, which will be another one of my roots. Okay, so using the quadratic formula, it goes ahead and it gives me my equation I'm looking for here. Okay, and it goes ahead and tells me what my roots are just by plugging those values into the quadratic formula. Works for if you have a leading coefficient. Works for if you don't have a leading coefficient. Doesn't matter. You can use the quadratic formula. Okay. We're going to jump ahead. We're going to do the third one together. I'm going to have you guys do the second one on your own in a moment. Let's do the third one just because there's a slight extra wrinkle of, hey, these things aren't all on the same side. This negative 44 is on the wrong side. I'd want to move this over here by adding 44 to both sides. And so I'm going to end up with x squared, let's make it look like an x squared plus 14x plus 44 equals 0. And now we'll go ahead and we'll do the quadratic formula. So the opposite, x is going to equal the opposite of b, so the opposite of 14, plus or minus the square root of 14 squared minus 4 times a, which in this case is 1, c, which is 44, all over 2 times 1. And then again, we're going to simplify it underneath that square root. You know, what I like to use is I'll use a calculator for that. I'll just go ahead and put that in. Make sure when you do that correctly. So I'm going to be putting in 14 squared minus 4 times 1 times 44. Although really I don't need to put the times 1, right? Because it's going to, 44 times 1 is just 44. So we can just do that. But underneath that square root, I'm going to get 20. So it's going to be negative 14, the opposite of 14, plus or minus the square root of 20 over 2. And now I'll go ahead and I'll simplify this square root of 20. So in this instance, I'm going to get that x is going to equal the opposite of 14 plus or minus. If you remember, 20 can be 4 times 5. 4 is a perfect square, so this is going to be 2 root 5 all divided by 2. Now, you kind of have two options of what to do here. Over here, I went ahead and I split this before I started adding and dividing and all that stuff. Excuse me. Because you have a square root here, you kind of know that you're not going to get nice integer answers. You're going to get some irrational answers with square roots and stuff. So what I'll actually do is I'll actually go ahead right here and cancel out this 2. I think that makes it a little bit easier, right? 14 divided by 2 is 7. 2 divided by 2. Because 2 goes into both of these terms, I'm allowed to do that. Do not do this canceling if it only cancels out with one of the terms, okay? It has to go into both of them in order for you to legally be allowed to divide this, okay? So I'm going to get that x equals negative 7 plus or minus the square root of 5. And to be honest, that's kind of my answer. There's nothing else I can really do with this. I could split it and say negative 7 plus 5 and negative 7 minus root 5, but that's the same thing as just saying this. So there's my two answers. It's negative 7 plus the square root of 5 and negative 7 minus the square root of 5. I'm going to let you guys go and try this one in 1 second. Let's just talk about real quick about when do you want to use which of these. So now that we have all three processes, when do I want to use them? So the first thing is I always try to factor first. You want to look to see if it factors. Maybe it's a factor pattern. Maybe it's just something you can factor. That's always kind of the first thing I'll try no matter what. Not every quadratic is factorable. But if it is, I tend to find that to be one of the easier ways to solve. Not to mention, later in the course, we start talking about polynomials. It's going to be very important that you can find those factors. So being able to factor in general is going to be something that helps you out later down the line. If I cannot factor, that's when I jump to the other two methods, the quadratic formula completing the square. Honestly, me personally, I'll do quadratic formula just about every time. I think that it's easier than completing the square. If you like completing the square, you can do that every time. Some people, the way that they'll kind of jump between them is if they do not have a leading coefficient. So if that leading coefficient is 1, they'll do completing the square because it's a little bit easier. If the leading coefficient is not 1, they'll do quadratic formula so that they don't have to do all that fraction math that can come up with completing the square in that instance, okay? But really, it's kind of up to you at that point which one you want to use. On a test, I am not going to specifically say, solve this quadratic or find the roots of this quadratic in a specific way. You will be allowed to use any of the ways that you like. However, there are going to be instances, we'll see later, where completing the square is going to help us with a process that we need to do. Same thing with factoring is going to help us with some other processes we need to do later on in the course. So there are things you're going to need to know. But if I ask you a question of, hey, here's a quadratic, I need you to solve it, or you need to find the roots of it, I'm not going to ever dictate to you how you can do that. You can kind of pick a way you like best and kind of lean on that while still knowing the other two ways for when there's something that you need for them specifically. All right? Why don't you all go ahead and try quadratic formula on this one and tell me what you get. We'll meet back together in a moment and discuss our answers. All right, me back looking at this problem here. I put in 1 for A, 3 in for B, and -9 in for C. Make sure you put in -9. That's going to really change this problem. So we're going to get 9 plus 36 underneath that square root, which equals 45. I recognize that 45 is 9 times 5. 9 is a perfect square, so I can pull that out. So I'm going to get -3 plus or minus 3 root 5 over 2. To be honest with you, nothing you really do to simplify this, okay? Again, just like this one, I could rewrite it out as -3 plus 3 root 5 over 2 and -3 minus 3 root 5 over 2. But this is kind of just saying both of those things in one problem. So really, if you kind of recognize, if you have a square root here and you're going to get irrational numbers, you don't necessarily have to do all the same simplifying we did over here to get two separate answers. This is showing you those two answers just kind of in one part there, right? The plus or minus is showing you that there. All right. Thank you all for watching, and I hope you know better about the quadratic formula. Please spend some time trying to memorize this formula. It is important that you know what this formula is. It's going to be something that you're going to need to know really for the rest of your math career. So make sure you know that formula. Thank you for watching.